And a very pleasant good afternoon to you. Welcome to Volume 2 of Weather School. No school, no problem. It's time to get a little educated with regards to several things, weather related, very much related, some interesting little facts. We will do our ABCs of weather coming up at the end, where I introduce you to some weather terms that maybe you know, maybe you didn't know, but I'll explain them all. And we'll run through about a couple, three interesting weather topics so that the next time you're either watching whiteboard weather or looking at a weather map, you have a better understanding of some of the things that are related to the world of weather. I'm glad to share this information with you, my love, my passion, my understanding, and my knowledge of the world of meteorology. So I'm very happy to pass that along to you. We will start with a little bit of a recap of last time. We'll build a little bit on what we did in Volume 1 last time, but we'll do a quick recap. I have my pointer ready to go, my handy dandy pointer. It's actually my son's, but I had to ask him if I could use it, and he said, yes, you can use it, Dad. So I have my weather pointer, and do you hear it? Do you hear it? The school bell ringing. There we go. It is time for Weather School, everyone. Welcome once again to Weather School this afternoon. If you were with us last time, one of the things we started off and one of the things that I focused on a good deal was weather maps and understanding some of the basic weather features on weather maps. And I wanted to sort of pick up on that once again. So we're going to flip perspectives back and forth so I can show you some of the information. I'm going to show you basically what a standard weather map looks like. When you see a weather map, often you'll see it looks like this. It has these lines, it has these letters, the H and the L, and it has the red lines. All of these mean something different. If this is new to you, you're going to be educated right now. If you were here last time, you're just going to get a little bit of a recap. Here's a little bit of what these things mean. The red line is called a warm front. The blue line with the triangles is called a cold front. The L is what's called low pressure. The H is what's called high pressure, and the line that has both blue and red attached to it is called a stationary front. Now, to give you a quick understanding of what some of those things mean, I break it down very simply. The H, or high pressure, stands for happy, because whenever high pressure is close by, you have sinking stable air, the sun is out, it is dry, and people, as a result of dry weather and sunshine, are happy. The L stands for low or lousy, because whenever low pressure is close by, that usually means there's clouds and oftentimes precipitation, which is generally considered lousy weather. One thing that I did not mention last time that I wanted to hit on is a lot of times people think the H stands for hot. High and low pressure really have nothing to do with temperature. That is more a function of the placement of the jet stream, which we're going to talk about today. But high and low pressure have no bearing on actual temperature per se, in terms of it being hot and cold. You can have high pressure across Minnesota in the dead of winter. It might be 10 degrees outside, but it could be sunny as all heck. So high and low pressure have more to do with clouds and precipitation than they do with actual temperature. And again, here's the breakdown of your fronts. A cool front, a warm front. They move in the direction that the triangles and semicircles are aimed. The one that has both on it is called a stationary front, not moving at all, which means the air is moving pretty much parallel to the front, so the front's not moving in any direction. And sometimes you see a purple front. That's called an occluded front. And basically what that means is that a cold front caught up to a warm front and sort of, it was like a zipper. It sort of zipped things up. So an occluded front is when a cold front and a warm front sort of zip her up. The cold front catches up to the warm front and sort of overtakes it. So that's what's called an occluded front. Again, high and low pressure, no bearing on temperature. What does have a strong influence on temperature is something called the jet stream. And basically what the jet stream is, it's a rapidly moving, what we like to call a river of wind. If you can think of a river of water, it moves in various directions, but it all flows in one direction. A jet stream is a river of wind in the upper levels of the atmosphere, and that really drives not only the air masses, the cool and warm air masses, but also the weather features. It helps to push high and low pressure along. So it is sort of the driving force literally behind the movement and the weather patterns that take shape over extended periods of time. Now the jet stream, a little bit about it. It sits about 6 to 9 miles above us in the atmosphere, and the average speed of the jet stream is 80 to 140 miles an hour. So it can vary in one location to another in terms of speed. It can be a little slower or a little faster in certain parts, all depending on how it maybe is curving. Sometimes you accelerate out of a curve so you can pick up a little bit more speed in the jet stream out of a curve. So again, it influences warm and cool air, and it pushes weather systems around the world. Now there's more than one jet stream, believe it or not. There's not one, there's not two, there are 3 different jet streams located and moving around the globe on any given day at any given time. And here is a breakdown. The graphics compliments from my friends at AccuWeather. The 3 jet streams are called the polar, which is up here at the top, the mid-latitude, that's the strongest, and then the subtropical jet stream. And they can all move individually, but they can also, is called phasing. They can sort of meet up sometimes and move together for brief periods of times, but most of the time they move apart individually. Now the position of the jet streams really indicates, as I mentioned, the temperature, the air mass movement across not only the United States but across the globe. Let me give you an example. Right now these 3 jet streams are moving in what's called a zonal pattern, or west to east, from one zone to the next. Instead of moving north to south, they're moving west to east. That's called a zonal movement of the jet stream. Sometimes though, the jet stream can look like this. You can see a big sort of rise in the jet stream over Alaska, then it dips down across the US and it bottoms out here in the southeast, and then it rises back up. So sometimes the jet stream will move in sort of a serpentine or snake-like pattern. That allows the cold and the warm air to move in relationship to the jet stream. So when it dips like this, that allows colder air to filter down from the north. Whenever it rises like this is called a ridge, it allows warmer air to expand further north. So the movement of the jet stream really helps determine the placement of cold and warm air masses. And one final thing, if you've ever been on an airplane, maybe traveling out to the West Coast, you may have noticed that it takes sometimes longer to travel from here to, say, Los Angeles than it does to travel from Los Angeles to Pittsburgh. That's because your airplane is moving in this direction. It is moving against the jet stream. That's called a headwind, when you're moving against a wind that's moving toward you. So when you're moving into a strong wind, that tends to slow you down. The reason it takes not as long to fly from here to here, have what's called a tailwind. The winds are moving with you and pushing you. So the same flight, say from Pittsburgh to LA, takes longer going to LA than it does coming back to Pittsburgh. So that is a little bit about the jet stream. The next thing I want to talk about, severe weather. And there are a number of severe weather hazards. Now we're getting into severe weather season in western Pennsylvania, which means at some point we're probably going to see all of the things you see in front of you, from tornadoes to hail to lightning to wind to flooding. These are what are called severe weather hazards. Most of the time we have severe weather hazards, lightning, wind, and flooding, but occasionally we have hail, and occasionally we do have tornadoes as well. One thing that I wanted to tell you about with regards to some of the severe weather hazards, and specifically lightning. Did you know that lightning causes thunder? It's not the other way around. Thunder does not cause lightning. Lightning causes thunder. Now, when I was a kid, like maybe some of you, my mother told me that whenever there was a thunderstorm, God was bowling. And the rumble of thunder was the bowling ball rolling down the alley. And whenever he got a strike, that's when you had lightning. It's nice. It's a nice way to sort of describe maybe to somebody that's younger about what may be happening outside. And it kind of puts your fear at ease. But with regard specifically to lightning and thunder, as I said, lightning causes thunder. Thunder does not cause lightning. And let me explain. This is the best way I've always explained it to kids when I would go to school visits. If my arms like this are the air, just the general air, lightning moves with such speed and ferocity that it literally cuts through the air. Think of a knife going through butter. That's how lightning cuts through the air. Think of the atmosphere as butter. Think of the lightning as the knife. Now, as the lightning moves through the air separates because the lightning passes. It displaces or moves the air. It happens so quickly and so violently, this displacement or movement of air, that as the lightning moves through, the air opens and quickly contracts or comes back together behind the lightning. So when you have that happening, this happens. And you get a sound effect. The sound effect is the thunder, and that's because the air gets displaced and then quickly comes back together. That movement of air moving apart and coming back together causes sound waves, which is thunder. And whether or not you hear a clap of thunder or a rumble of thunder, that is more indicative of how far away the lightning occurred from your location. When you hear the clap of thunder, it's close. When you hear the rumble, you're further away because the sound waves then start to spread out a little bit and it gives that rumbling sound. But just so you know, lightning causes thunder. Thunder does not cause lightning. One of the hazards of thunderstorms. The other thing that I wanted to hit on today is one of the hazards of thunderstorms that does sometimes the most damage, at least for most of us, and always takes the most life. Every year, more people die from flooding than any other thunderstorm hazard. And we have in our area our fair share and then some of flooding because of all the streams, creeks or cricks, rivers, a lot of tributaries around western Pennsylvania. So we have our fair share of flooding. But every year, the number one cause of death of any of the thunderstorm hazards is flooding. So it is important to understand how impactful flooding can be, and especially it doesn't have to be a large-scale flood where lots of things are underwater. It could be a very small amount of water that could do a fair amount of damage and potentially put you or your loved one in danger. Let me explain. Important information here. When you see floodwaters, if you're out driving specifically or even looking at them, you never really know how deep the water is until you actually get in it, which is never recommended. Some important information. 6 inches of fast-moving water, just 6 inches, can knock over and carry away an adult. 6 inches. If you move it up to 12 inches, 1 foot of fast-moving water can carry away a small car. And finally, 18 to 24 inches of fast-moving water can carry away most SUVs, vans, and trucks. So as little as 18 inches of water moving fast enough is literally going to carry away you, your small car, or your SUV. Water, my friends, is very, very powerful. That's why we always say When you see any water covering a roadway, turn around, don't drown. This is Western PA. We all know there's probably 10 different ways to get from point A to point B. So it's never worth it to drive through flooded waters, turn around, and find another way. So that is important information about flooding. A very little amount of water can do an awful lot of damage with regards to putting yourself and your loved ones in danger. Turn around, don't drown. Now, do you know the difference between floods and flash floods? Because I think a lot of times, all my 25 years of weather experience, people sometimes use the two terms interchangeably, like they mean the same thing. They do not. There are many differences between floods and flash floods. And let me explain those differences to you, because it's important to understand the difference. For that, we're going to go over to one of my very favorite tools to use. It's called the WhiteBoard. And we're talking about the difference between a flood and a flash flood. Let's start with a flash flood, because we see an awful lot of these. A flash flood is similar to what exactly the terminology states. It is literally water rising in a flash. Too much water, too fast. As a result, storm drains cannot handle the amount of runoff that is coming at them in a short period of time. Now, flash floods are typically isolated in their coverage. They could affect maybe one or two streets, but one or two streets over, there's no flooding whatsoever. So flash floods are more isolated or localized in their coverage. They're a short duration type of flood, typically an hour or less in many locations. As quickly as the water rises, once it stops raining, the water will quickly recede, because a lot of the sewers will catch up and take care of the runoff. So they're short duration events. Again, they are quick to develop. They can start happening in a very short period of time with very little warning whatsoever. And they usually happen on small bodies of water. Streams and creeks is most of the time where you see flash flooding occurring. Floods, take away the flash, now we just have a flood. It is a prolonged rain event. Instead of too much too fast, you have a considerable amount of rain falling over a large area over an extended period of time. So they're prolonged rainfall events. They impact larger areas. We talked about flash floods being isolated. Floods impact much larger areas. Many more people are impacted, and many more acres of land are impacted. They're a longer duration event, whereas flash floods maybe last an hour or two at most. Floods can last for days. They're a longer duration. They take longer to develop. You don't see the quick developing flash floods. Actual floods can take hours or days to develop as the water runs off into larger bodies of water. Floods typically impact larger bodies of water. Flash floods are the smaller bodies of water. So that is the difference between a flood and a flash flood. And as always, if you ever encounter a roadway that is covered in water or a sidewalk or anything, turn around, don't drown. So that's the difference between floods and flash floods. Very important information to know the difference. Now, one final thing I want to go over before I get to some of your questions and our weather alphabet for today. Last time in Volume 1, I did have somebody ask me about tornadoes. Now, tornadoes are very complex weather features because when you think conditions could be absolutely ripe for a tornado, sometimes they just don't develop. It takes a very finite set of absolutely perfect circumstances for tornadoes to develop. We talked about it last time. Supercell thunderstorms on average only about 20% or less of the time produce tornadoes. That means 80% of the time when you have a supercell, no tornado falls out. So there is that. Now I will give you, and I'm going to show you some of the conditions that come together to make a very ripe environment for tornadoes, and it involves winds coming in from different directions. We use a big term, it's a small word, but it's a big term, it's called shear, wind shear. It's winds at different levels coming in from different directions. You have a wind here coming this direction, a wind here coming this direction, and that starts to give spin or rotation to the atmosphere. Let me show you this graphic and explain it a little better for you. This is sort of some of what it takes, some of the ingredients it takes for tornadoes to form. First, you need rising air. You need usually warm, moist air that starts to get a good push or rise in the atmosphere. Rapidly rising air that punches up very high into the atmosphere. It goes through several layers of the atmosphere and meets up with winds aloft that are moving in a different direction. Now you're going to start to get what's called a cumulonimbus cloud, a big cloud that's a vertically developed cloud that can go up 50, 60,000 feet, and it's going to start to look very dark and thick because it's very dense. There's your winds from different directions will cause the storm to start rotating, and if the conditions are just right, a tornado may drop out of the base or the wall of that particular, the wall cloud of that particular thunderstorm. So it is a variety of things. This is a very simplistic sort of list of ingredients, but you need warm, moist air to get a good push and a good rise to go all the way up in the upper levels of the atmosphere. And then as some of those winds come through a downdraft, winds from different directions will start the storm rotating, and then you may get your tornado. Now, I don't know if you know the difference here. Here's another couple of terms. Funnel cloud versus tornado. You know the difference? Anyone? Anyone? Bueller? A funnel cloud is a twister that drops out of a thunderstorm, supercell thunderstorm, but never touches the ground. So you can see sometimes a storm that wants to drop a little funnel, but it never touches the ground. Once that funnel or cone touches the ground, it becomes a tornado. So there is a difference between funnel clouds and tornadoes. And the one other thing I wanted to show you here is what's called the EF scale. It's the system of ranking and rating tornadoes after they have passed. It's based on the amount of damage that tornadoes can do. There are 6 different ways to rank a tornado, from what's called EF0 to EF5. Now around here, most of the tornadoes that we get rank between an EF0 and an EF2. And probably of those 3, most are probably EF0s to EF1. So we generally get light to moderate weak tornadoes. The stronger ones, the EF4s, the EF5s, are usually the ones that happen through Tornado Alley, where the conditions are very favorable at this time of year, springtime. And those winds can be greater than 200 miles an hour for an EF5, or they can be as little as 65 miles an hour with an EF0. But again, these are all ranked after the fact, not during the event, but after the fact. The National Weather Service will send out a survey team, a group of people. They'll go out and look at the damage, and they'll figure out how much wind did it take to maybe take some shingles off of this roof or knock this tree over, or how much wind did it take to knock this whole wall off or take this whole roof off of a garage. So tornadoes are ranked after the fact, not during the event. So that's a little bit about the ranking scale for tornadoes. It's called the Fujita scale, and it was enhanced to include some greater parameters a few years ago, so that's why it's called EF, the enhanced Fujita scale. So that's a little bit about tornadoes and a little bit about the ranking. Now, for those of you that did send in questions, I do have a handful here that I want to get through very quickly. Ben from Beaver sent in a question, and he asked, Ben is 6, by the way. he asked, and this was on Instagram, he asked, how does the sun make us warm? It's an excellent question, Ben. The answer is this. As sunlight comes in, what's called solar radiation, big term. As sun comes in, not only does it bring with it light, but it brings with it radiation. Think of almost like an X-ray being radiation. And when this radiation reaches the Earth's atmosphere, it warms up the molecules, and then once one group of molecules warms up, it warms up another set of molecules, and then it's just almost like a domino effect. One after another, the molecules warm up because of the incoming radiation. So that's how the sun warms us up. Another question from Adam. He's 11. He asked, what causes thunder snow? Thankfully, we didn't have any thunder snow this year. But basically, it's not all that different from thunder and lightning in a thunderstorm. It just happens in a snowstorm. It is a little bit more rare, though, because you really need strong upward motion or winds moving very quickly up through the atmosphere. That doesn't typically happen with most snowstorms. You need a really powerful area of low pressure to kind of get those dynamics and that sort of lift in the atmosphere. It is relatively rare, but it is more common that it happens in and around the Great Lakes area because you have sometimes a big temperature difference between the water of the Great Lakes and the cold air, and that adds extra what's called instability to the atmosphere. So it is a little more common to get thunder snow around the Great Lakes area. Vinny asked, is it possible to have a thunderstorm with high pressure? When it comes to the atmosphere, I don't want to say anything is impossible. It's highly, highly, highly unlikely because high pressure brings sinking stable air, and to get a thunderstorm, you need rising air. So the two really don't mix. So as close to I can say it's impossible, I'll say it, but nothing is impossible when it comes to the atmosphere. And one final thing, this has an interesting statistic with it. Sherry asked, how come the Pittsburgh area can get every type of weather in the same day? That's just a function of changing air masses. Really, sometimes you can get a big push of warm air followed by a collapsing cold front that brings a big change in temperature. It's not just happening here. It happens everywhere. And I'm going to give you an example. In January of 1943, in a place called Spearfish, South Dakota. Check this out. This is interesting. In Spearfish, South Dakota, if you woke up at 7:30 a.m. to take your dog for a walk, the temperature was -4. By 7:32, 2 minutes later, the temperature had risen 49 degrees to 45. You heard me. 7:30 it was -4. 7:32 it was 45. By 9 o'clock that morning, the temperature had risen to 54. So from 7:30 to 9, the temperature went up 58 degrees. And then by 9:27, 27 minutes later, it was back down to -4. So in the course of 2 hours in Spearfish, South Dakota, in January of 1943, the temperature went from -4 in 2 minutes to 45, up to 54, and then back down to -4. That is all seasons in one day. So it's not just us. All right, let's get my teaching assistant in here, my teaching aide, Miss Shelley. And we're going to go through our weather alphabet, give you a few terms that maybe you didn't know or weren't aware of. There's the lovely Miss Shelley back there. She's going to hold the camera for me, and I'm going to head over to check out the whiteboard. Miss Shelley, if you wouldn't mind. Okay. Oh, I need my pointer. All right. This is the weather alphabet, my friends. Let me get that to hold up. Last time we did A, B, C, and D. Today we'll pick up with E. One of the first weather terms in E is El Nino. We've all heard the term El Nino. It is Spanish for the child. It got its name El Nino because it was first discovered off of the South America coast happening frequently around Christmas. So the child, Jesus, it got the name El Nino. What it is, it's in the equatorial, the equator part of the Pacific, the water sort of reverses and it gets warmer off the South America coast than it normally is. That's what El Nino is, the child. I. We're talking about the eye of a hurricane. That's what E stands for. The eye of a hurricane, the center of the hurricane. Most of the time, on average, the eye of a hurricane is between 20 and 40 miles wide. The smaller or tighter the eye is, the more powerful the hurricane. So if you get a hurricane that has a 20-mile wide eye, it's usually a pretty strong hurricane. If you have a hurricane that has an eye of 50 miles, it's typically going to be weaker. We go to F, fog. There's San Francisco, there's fog. Basically, a cloud forms close to the ground. In this case, the Golden Gate Bridge went over top of the fog. Frost. There's frost. There's frost. We've all seen frost. You know how frost forms? Frost forms whenever you get water vapor, it's a gas, water vapor, in an area of the atmosphere where the temperature is above freezing. We'll say 36. That water vapor then comes in contact with a solid surface, we'll say a car windshield, that is below freezing. The water vapor goes from gas to solid as it makes contact, and it goes to ice that develops on your windshield. That's how frost forms. Water vapor in an above freezing atmosphere meets a surface that's colder than freezing. And of course we talked about flood and flash flood. All right, let's get to the next ones. Let's start with gully washer. I learned about gully washers when I lived here, Texas. What a gully washer is, big burst of rain. Heavy rain over a short period of time, and in Texas we call them gully washers, which is actually a weather term. We occasionally get a gully washer here, but that's what a gully washer is, a real extreme downpour of rain. And then the other one, grapple. Have you heard the term grapple? We get grapple around here. It's often confused, grapple is, with hail or sleet. And it's kind of a little bit of both. Hail is something that occurs in thunderstorms, typically in summer. And hail goes through a thunderstorm, and the more the hail goes through a thunderstorm, the bigger it gets, and it's just layers of ice on top of layers of ice. Sleet is something that typically falls in winter, and it's based on snow falling, reaching a certain part of the atmosphere where it's warmer, it melts, and then it gets colder again and it refreezes. So sleet is a snowflake, then a raindrop, then a frozen raindrop. That's what sleet is. Grapple is a combination of the two. It's a snowflake that is falling, it's cold enough to have a snowflake, and then you get super cooled water that develops around the snowflake. So it's kind of a combination of hail and sleet, and grapple is also called soft hail. So that's what grapple is. Finally, we have a hygrometer, or as my wife said, hygrometer. She gave me the eyes. You had to say that, didn't you, Mr. Jeff? Yes, hygrometer. It measures humidity in the atmosphere. It's an actual weather instrument, but many of you probably have your own hygrometer, your hair. You know when it's really humid outside, your hair gets really frizzy and big. Hygrometer measures humidity. And finally, this is my picture for heat wave. A heat wave is a period of excessively warm temperatures in relationship to what is considered average. In Pittsburgh, we have a different definition of a heat wave than, say, they do in Phoenix. In Pittsburgh, a heat wave for us is defined as 3 or more days of temperatures at or above 90 degrees. That's our criteria here. Now, if that was a heat wave in Phoenix, they would have a 6-month heat wave every year, because as we know, temperatures in Phoenix in summer typically get to 100 degrees or better. In Phoenix, they typically will start using the term heat wave when the temperature gets to about 114 or 115. Excessively warmer than what is considered average. So the term heat wave means different things in different parts of the country. At least the criteria change from one place to another. So that is your weather alphabet, E, F, G, H. Thank you, Miss Shelley. I appreciate it.
No problem.
Let's flip the camera around. There you go. There is your ABCs of weather. Thank you to Miss Shelley for helping out here today. What am I sitting on? My glasses. I don't want to break those. That is going to do it for today. Thanks for tuning in to the weather classroom today. I enjoyed having you here. I was trying to bring up our bell to say school's out. There we go. I enjoyed having you here today. You can always check out a lot of weather information, a lot of cool weather information. That just means class is over. Check out cool weather information at pittsburghweathernow.com. That is a website where you'll find a lot of weather records and other weather information that you can use and educate yourself anytime. Thank you for joining me again here today. We'll plan on doing this again next week. Please share Weather School with as many Facebook friends as you can, anyone you think would enjoy being educated at least a little bit about the weather. And we'll do it again next week. Have a great afternoon, everyone. Peace. Blue skies.